Hello and good morning everyone, and thank you for joining our VMware NSX webinar today. So we're joined here by Paul Manaton from Avnet, who will be going through the webinar with you. Okay, just before I hand over to Paul, I'm just going to go through a few housekeeping details with you really quickly. So you will be muted throughout the webinar, but we will hold a Q&A session at the end. So if you do have any questions, you can just pop those on the right-hand side of your screen. There's a box, just pop them in there. And if you would like to request a callback from Bytes, you can pop that in there at the Q&A session as well. So we are recording the webinar today, and I'll send you all a link to the recording this afternoon. Okay, so I'm now going to pass you over to Paul.
Good morning, everybody. Thank you for joining us. So today we're going to go through the NSX proposition and what NSX is. We'll do a quick presentation using PowerPoint, and then we'll go and have a look at the actual product itself. So I'm just going to share my screen. So hopefully you can all see that.
Oh, we can't see it.
Oh, can't see it. Hang on, I've got to click on that button. There we go. You should be able to see.
Perfect.
Good. Okay. Right. So, what is NSX? So, hopefully everybody's familiar with the concept of the software-defined data center. Basically, software-defined data center takes everything that we traditionally think of as data center and turns it into a software-defined entity. Why is that a good thing? Because it means that we gain more control. So VMware started by doing this with server virtualization. So we took the hardware that made up servers and we defined that as a software entity, as a software container. That allows us to define and extend it dynamically. But, you know, we've kind of hit where we need to be with this stuff. And the industry, the world has moved on. I'm constantly having conversations with people around how actually what's driving things these days is consumer, not enterprise. Enterprise is being driven to become consumer, to become agile, to become reactive in the same way that consumer is being driven. And so what's driving this is that kind of mentality. So where does NSX come into this? NSX allows us to virtualize that network segment and move that up above and into a software-defined layer so that we can react very quickly, so that we can secure things very simply, so that we can protect people's privacy, protect people's data, so that we can isolate. So the analogy that you'll hear time and time again with NSX is that of the hotel and the castle. So let me explain that. So if you think about how we've done security typically, it's how we used to do security in the Middle Ages and in medieval times. We would build a building that would have very thick walls, very strong outer defenses, and that would protect people inside from access from the outside. So it'd be very difficult to breach that wall. But once that wall was breached, you were inside, and everything else inside was very easy then to get to. There was no defenses internally. And that's kind of how we've done security. We have these firewalls on the outside, quite difficult to penetrate, very difficult to get into our inner sanctum. But once you're in, there's very little protection within the machines and the security within inside that. But if you think about a hotel model, when you check into a hotel, they give you a card key. And it's quite easy to get into the reception. Although you're being watched all the time and we're being monitored, it's easy to get into reception, you can check in. But then once you get to inside, you need access to each individual room, and each individual room is protected and logged. And that makes more sense because we've now got control over everything individually, a very granular control, but very secure. And that's kind of where NSX comes in. So this is a new approach, and it's a new approach to the whole data center. It's agile, it's efficient, and it's secure. We've got this hotel approach to security. so that we can manage security at a much more granular level, but also do things much more quickly. And as I said, it's about this software-defined data center, defining everything in software, which makes things more manageable, it makes things more agile, and it makes things much easier to do. So this is where we are now, where we've come from. So the enterprise data center, we had compute, storage, and networking. Well, they were all defined in hardware, so we're familiar with all this stuff. And what do we do in the networking? We do security, we do load balancing, we do routing, we do servicing. But now we've got these customized distributed applications that need more protection, and we need to simplify that. So now we've got this data center virtualization layer that allows us to bring all that into software defined. And now we have, it's basically, we've virtualization to the hardware layer. We've now enabled ourselves to create virtual machines easily. We could snapshot them, we could store them, we could move them, we could vMotion them, we could delete them. And now that's what we're doing with the network. So now we've got to bring that into the data center. Now, you've all got networks. You've got physical networks, you've got switches, and you've got routers. What we can't do, and what we're not going to do, is ask you to forklift that out and move something else in. We need to be non-disruptive in terms of deployment, even if it's a disruptive technology. So the virtualization layer just sat on top, and that's what we want to do with the network, is we want to bring the network your existing setups. And this is what NSX will do for you, because we don't need to forklift in new networking hardware. We can bring it in and sit it over the top of your existing network and put in that network hypervisor, which is a term that's been coined a lot, over the top of everything else. And then we can set up those virtual data centers, those virtual machines with all that interesting networking and all that security and all that flexibility and agility over the top of that. And what we're trying to do here is we're trying to distribute the services. And why is that a good thing? Well, one of the things that we do with NSX is we take that firewall that's currently on your edge in physical, and we bring it in and we put it at the virtual machine level. So it sits at the network interface card level of the virtual machine. That means that we get the power of every single ESX host and all the throughput of every single ESX host, and we bring that to each virtual machine. So we're not affecting performance. We're also setting up things like logical switching and logical routing and load balancing all at that level, so that we can bring all that into the virtualization layer, which gives us high throughput. And here what we're really concentrating on is not that north to south information, which is the data that's coming from the outside world into the virtualization layer. We're focusing on the east to west traffic, the traffic that's going between virtual machines. Obviously, we do care about the north to south, and we deal with that as well. But the security breaches are coming about because of the east to west stuff. And it's allowing us to think about things in a different way. So we can actually set up logical networks, which are like any other logical entity defined in software, and then tier our applications, and then define what goes between applications. And one of the things that I personally love about NSX is the fact that I can define a service based on what virtual machines I want to sit in a service. So I can define what is the web tier by simply saying any machine with the name web in it is in the web tier. Any machine with the name app in it is in the app tier, which means whenever I create a new virtual machine, all I've got to do is call it web, and it gets all of those security profiles associated to it automatically. Where this really comes into its own is when you start to try and automate this, start to try and make it repetitive and de-risk it, because it allows us to define these things and apply them through automation. And that's everything from internal cloud to external cloud. And before too much longer, it'll all just gel together. We'll be able to move things between the two. In fact, we're beginning to see that already. So we already know about virtual switches, probably. It's a virtual entity. It does what a switch does, and it allows us to set up VMs and connect them to the network. And it routes between VMs on a single host. It's very easy. As soon as it goes out onto a physical network, we actually have to use the physical network and go through physical switches to route through. So that's layer 3 routing. We're doing that already. You know, that's something we're probably very familiar with. Although, interestingly enough, I was having a discussion with somebody the other day. People seem to forget that the network exists these days. It's something that's taken for granted. Now, if we introduce a virtual network, that sits over the top. And the VMs talk through the virtual network rather than through a physical network. And we don't want to go out onto the physical network. We don't want to convert things back for physical. So what we do with NSX is, rather than do that traditional layer 3 networking, we impose this logical network over the top. And the logical network allows us to route layer 3 traffic over a layer 2 traffic over a layer 3 network. It uses a thing called VLANS, but we don't need to worry about that too much. But it allows us to run that without any interaction, so that we're totally independent of what's underneath. It also allows us to do this programmatical provisioning. So that means that we can say, because we have full control, we can say, I want this to go to there, and I can do it all from a software interface. And we can define all of our rules, all of our security at that logical network, and then worry about how it works over the physical network inside the logical networks. So we don't have to worry in the physical network about anything like VLANs or ACLs or firewall rules, because we're just going to encapsulate that traffic and it's going to be dealt with in that logical plane. It also allows us to do isolation at the network layer, which means that we can run different physical networks over that logical network, or different network domains over that logical network. So in this example, we've got two 192.168.2 address schemes over the same physical network because they're completely isolated. We never see those addresses on that physical network. That gives us ultimate control. Now, many of you will have looked at DR at some point, and one of the challenges of DR is this networking, because you've got a primary site with one address scheme, a secondary site that needs a different address scheme, and then we have to re-IP address the virtual machines when we bring them up on the recovery site. We have to test that, and we have to deal with all the DNS issues that brings about. So what we're effectively doing is we're taking a snapshot of a VM, we're then replicating it across to the other side. If we recover the VM, we then got to do some kind of change configuration, not just on the VM, but also on all the DNS and everything that points to that. But if we do it with NSX, we've now got an NSX network that's across the two sides, and we can do the whole network security as well. There's no re-IPing needed. It's on the same address, so all of our DNS also works. And so this also comes into its own with our DR policies. We do support physical workloads, so we can bridge into our physical network using either an x86 gateway or a virtual machine. That allows us then, therefore, to take into account the fact that we've still got physical machines out there, we've still got workloads that haven't been virtualized. And what we do is we bridge between a logical network and a VLAN, so that we can bridge out to, say, our Oracle database. We also interact with those top-of-rack switches, which we can interact with because we actually have a connection with them. We integrate with those top-of-rack switches. So people like Cumulus, Juniper, Cisco to an extent, we can interface in with those and use features on those. So things like the VXLAN, we can use physical endpoints on those top-of-rack switches. We don't have to, we can completely ignore them, but it obviously makes things simpler if we can interact with those. So in the old days when we used to have to go in, we had this hairpinning effect where we had to go out to the physical, back into the virtual. Where we don't need to do that anymore, we can now come straight through the virtual switch on a single host. On a multiple host, we can just go into the fabric. We don't need to go to the switches, which makes life a lot simpler, makes traffic a lot quicker, and makes things generally much easier. We talked about this east to west piece of technology where we're trying to manage the traffic between virtual machines. In a traditional setup, we would either ignore that and we wouldn't firewall it at all, or we would have to come out, hairpin, firewall the traffic outside in a physical environment and then bring it back in again. That's a nightmare. The number of rules that you've got to do, the number of firewalls that you would need, the licensing for all this is terrible. So we're left with the situation where we either don't do it, and that's not going to give us the security, or we do it and we've got a management headache every time we try and introduce something new. So NSX brings this and makes it much simpler. So because we've got this ability to create a firewall at the virtual machine level and manage the rules at a virtual machine level, we've simplified it greatly. So we can have a VM connected to our vSwitch on our logical switch, and we can define the firewall rules at that level. If we then move that VM, we don't have to suddenly redefine all of those perimeter security firewall rules. They're defined at the virtual machine layer. We don't have to make any changes at the physical layer. They're all defined and we can move them with the virtual machine. And in fact, it's automatic. We don't even have to think about it. And it's done via a thing called a security policy. So within a security policy, we can set up a policy that specifies what the security needs to look like, and then assign it to a virtual machine or a group of virtual machines, which is actually more important. We can also then audit that through logging, so that we don't have to, so that we can just demonstrate that to our security concerns and our investors in terms of technology. And there's a huge difference between physical firewalls, even virtual firewalls, and distributed firewalling. So distributed firewalling is making life a lot easier. It gives us the same throughput. I'm going to demonstrate that in a minute. So we don't lose anything by doing this, really, not significantly. The throughput is 20 gig-ish, which is similar to that of a standard physical firewall to a host, and we get similar throughput. This all comes to this point that we need to get to, which is zero trust. You may have heard this term bandied around a bit, which is that we don't trust anything, and we assume nothing and make everything untrusted, and then trust only on certain ports, etc., which we can now do. NSX makes this zero trust environment a feasible approach. In fact, it's native. It kind of is out of the box. That's how we're going to do it. And microsegmentation, which is this hotel approach, is now feasible with NSX. And it allows us to say, right, okay, we need to control things in an appropriate manner to what we're actually protecting. So we can now explicitly allow traffic between different tiers, different layers of our application. And also, you know, sometimes NSX isn't going to be the best place to do this stuff, so we can pass some of the interesting stuff out through Service Composer to something that does it better. So if we're doing antivirus, if we're doing IPS or intrusion detection, then we can pass that out to something that does it better. So something like Palo Alto or something like Checkpoint or Trend, which allows us to pass the information through introspection out to a device that we can use to do a better job maybe than VMware could do. And this is the service insertion. So we are able to pass that stuff out via service insertion through the NSX framework to things like Palo Alto's next generation firewalls. Typically that's going to mean that we're going to put a virtual instance of that into our environment. And we're going to set up a security policy that says we need to do that, pass that information out through the virtual switch, through introspection, out to a third-party device and steer that traffic out. And I kind of intimated about this earlier, that we can group things in our services via pretty much anything we like. It's intelligent enough to be able to tell what the operating system is, machine name. We can define regulatory compliances. We can use tags, service tags, to do this. So the example that you'll sometimes see shown is we can put a virtual machine on a network called production. If Trend Micro or one of the other AV solutions sees a virus in a machine, it'll tag it as infected. That then means that it goes into a service group called infected. We can then deal with that infection, and as soon as we've dealt with that infection, we can move it back onto the production network. All that happens in the background simply by changing the tag. So we've got this intelligent grouping. We're very quickly able to change what services and what security machine gets just by changing its group. And so that makes things a lot easier in the data center, because we can define things and define what security profiles it needs, and no matter where it's sitting, it'll get that security profile, even if it moves. So why is this great? Well, microsegmentation gives us that extra layer of security. Microsegmentation allows us to set up a DMZ anywhere we like. It allows us to deal with end user security. One of the big things that we're talking to people about at the moment is where we're looking at VDI, and we can isolate individual desktops very easily with no extra cost, because we're not having to put physical firewalls in place. The ability to spin new services up very, very quickly, because we can define that security by simply putting it into a group. Very straightforward, very agile, and very quick to do. And application continuity. So not only with the disaster recovery, but also with the disaster recovery, in that we can keep the IP addresses the same, but also if we move it from site to site, if we've defined the policies, we can keep that policy when it moves to a different site. And if we're moving it into the cloud, we can define that policy in the cloud and move it into the cloud in the same way. So we can keep that security policy the same. Lots of physical infrastructure, security and operations, and application delivery partners are taking this on board. They're adapting and providing us with services that we can use, from physical switches that have VTAP endpoints, which are the VXLAN endpoints on them, to things like Palo Alto that allow us to pass traffic to their virtual appliances. Obviously, this is all available for VMware. this is part of people's journey to the cloud. The thing we hear a lot about cloud is that the security is a big concern, and NSX starts to help us to address that, because it means that we can be assured that the security we have in the cloud is the same. So VMware's invested a lot of money in NSX. It was a purchase that they made quite a while ago, and NSX is now being widely adopted among partners. There are other things you can do. So there's some resources on VMware's website. The demo I'm about to show you is actually a lab in VMware's hands-on labs that you can look at, and obviously there's training that's available to you. So what I'd like to do now is I'm going to go back in and I'm going to go into the lab. So bear with me while I get that. Amy, are there any questions at the moment?
No questions here. There are a couple of seconds of audio that were lost, so I'm just hoping everyone else can hear you okay. But other than that, no, there's nothing. Okay, actually we do have a question which has just come through from Andrew. He said that you mentioned vRealize Network Insight tool for generating rules in a brownfield site at VMworld recently. Is this a free or paid for thing?
That's paid for, I believe, because the Network Insight tool is a paid for tool. But we can double check on that. Unfortunately, I wasn't actually at VMworld.
Okay,
but
yeah.
Hopefully we can see that now.
I was going to say, Andrew, yeah, we can take that offline if you like, and get back to you with some more information.
So hopefully, can you see that screen now?
Yes, yeah, we can.
Let's go full screen.
Oh, we just lost it.
Oh, hang on, I've just got to click on play again. There you go.
Perfect.
Hopefully you can see that. Yeah.
Yeah.
Let's get that out of the way. Right, okay, so this is actually, we're now actually looking at NSX. So hopefully, I'm just going to change that screen res. Sorry, let's drop back again for some reason, don't know why. That's better. There we go, much better. Hopefully you can still see that.
Yeah.
So this is what NSX looks like when we've got it in our virtual environment. So the key thing here, first thing really, is the NSX dashboard that shows us what's going on. So this will interface in with all sorts of other tools. So we kind of mentioned Network Insight, which allows us to look at our existing network and then map policies. But this is our basic management information. We're looking at the infrastructure of NSX. NSX consists of 4 components in a default, which is our NSX manager, which is the overall management piece, and then controller nodes that actually are responsible for distributing things like the firewall rules, managing our edge devices, which are more like our traditional devices. So you can see all that here. This is a nice healthy environment, so nothing going on that we need to worry about. The installation of NSX is very straightforward. We just need to install a small piece of code on each ESX host, and if we look in here, we've got a couple of clusters. and hosts with the agent effectively installed on it. Again, we're seeing this straight from here, from the vCenter client. So we're managing this at the very basic level. And we've got logical networks and we've got service deployments, but we'll look into those in a bit more detail in a minute. So the key thing here is this logical switch idea which we talked about. So what we've done here is we've defined logical switches for each of the things we really care about. You'll see in here we've got an app tier, a database tier and a web tier, as well as a Windows tier and a couple of others that aren't really too relevant to me at the moment. We'll look at those in a bit more detail in a moment. And then we've got NSX edge devices, and these are physical, sorry not physical, these are actual virtual machines, physical is the wrong word, these are actual virtual machines that are doing what we traditionally associate with edge devices, so things like DHCP can be done here, NAT firewalling, all of the things that normally happen on that north to south edge gateway. And then we've got firewalls, and this is the distributed firewalling, so we can define rules in here, just like an ordinary firewall, a physical firewall, but these are for distributed as well. So you'll see here we've got flow monitoring going on, we've got services going on, and we can add into this section if we want to, and we would do to configure things. This is the clever piece, this is the service definitions. So this allows us to define those policies that we want to for the microsegmentation or anything else that we need to do between layers. And there's service managers, and there may be hardware devices out there as well. So I don't think we've got anything here, no we haven't at the moment, but that might be your Palo Alto. And the piece that allows us to really make this clever is this service composer. So within service composer we can define services, and I'm just going to go in and show you quickly how to do one. So we'll say web. I'm lazy, I'm not going to put a definition in. What I really wanted to show you was this piece where we can define what's a member of that service definition. So we can do it by computer OS name, computer name, VM name, security tag, or an entity. So we can pretty much do anything we want. We can also say matches any or all of the rules, and we can have multiple rules. So we get very flexible in here. We can also say, I'm going to close that one out. I'm going to start that one again. We can also say we want to exclude stuff, so I'm going to call it web again because we didn't actually say that one before. Next, I don't have to define anything in there. I can move on to, I can then exclude objects as well, so I can say exclude specific objects. And then I can complete that. So I'm able to define at a very high level what is included in a security policy and what's excluded from a security policy. And that gives me the flexibility. And then I can define, in addition to that, I can define those rules in my firewall, what can move between security policies and what actually happens within that security policy. All from my vCenter. I don't have to leave the vCenter at any point. Oh, the security stopped. So just pull this back to the presentation. Here's my logical switches. These are set up as layer 3 over layer 2 over layer 3 networks, which I can define these in exactly the same way as I do. I connect my virtual machines to these logical networks. I can then define in my service composer and my service definitions what can move between the two different tiers, or multiple tiers or logical switches, to give me that security. And we have security policies. We even have a canvas, which means that we can draw. This allows me to draw the mappings between the different pieces and link them together. So I've got a graphical interface if I want. I'm a command line kind of guy. I don't like GUIs very much, but this is for those who do like GUIs. Hello?
Hi, I think we might have lost you there for a minute. There was an issue with audio.
No.
It was just literally about the last 20 seconds we lost.
Oh, right, okay. So I was just summing up. So the logical switches are our transport. The service composer and service definitions allow us to define how traffic moves between those transports, and that gives us the isolation that we need to give us the security, the east-west security that we're looking for. I think that was all I said.
Are you still there, Paul?
Yeah. Are you not hearing me?
No.
That's odd.
I don't know if it's just me or if there's anyone else. I can hear you now.
Okay, let's open up for questions, and then if there's any questions about what we said, then.
Okay, we do actually have some questions here. Right. So Stuart has asked, if you're using purely the endpoint protection, do you still require to prepare hosts? In a test environment, when we attempt to prepare hosts, it says the license does not allow this.
So endpoint protection is that you can do endpoint protection through NSX, but endpoint protection is still available through introspection. So if you're just using endpoint protection, no, because endpoint protection is separate to NSX if you're doing it that way. I think that's what we mean. I mean, if you've got deeper questions, we can look at that on us offline. But endpoint protection and the antivirus features of NSX are two separate things.
Okay, thanks, Paul. And someone's just said that they could hear, so it must be my headphones that've got the issue. So we have a question here from Andrew. So it's besides, is it HOL? Does Paul have any recommendations for getting up to speed with NSX official training?
Yeah, so there is actually now a VCP for network virtualization. So there is an install, configure, and manage for NSX. The whole is good. There are 4 labs in the whole now dealing with, this is the 101, but just because this gives me a basic setup that I can show you. So obviously the whole I would recommend. So yeah, there's official training, and there's the whole as well to give you some hands-on experience. And there is now a VCP for network virtualization, the VCP-NV.
Okay, thanks, Paul. So I think that's all the questions we have for today. So thanks everyone for joining the webinar today, and thank you, Paul, for presenting as well. I'll send you all a link this afternoon, which will have the webinar recording, which you can all watch if you have been interrupted or haven't been able to watch the whole thing. And if you would like a follow-up call, then just please do let me know, and I'll get one of our specialists to get in touch with you. Okay, thank you everyone.